the properties of del of t, that is impulse signal. So why I am discussing these properties now? Why? Because now you know the time scaling, time shifting, and time reversal operations. That is time operations and amplitude operations, and you also know the condition for uh, even symmetry and odd symmetry. All these things you know now. So now I can freely discuss these properties so that you cannot get any doubts. Okay. So I need all these things to discuss these properties. That's why I waited till now. So first, the first property is del of t is even signal. So what is the condition for even signal? X of minus t equal to x of t. So del of minus t equal to del of t. So if you draw the graph, then you can see. So this is t. So this is del of t. T equal to 0 only signal exists. Okay. This is del of t. So if you fold the signal about y-axis, you will get same signal. Okay. So this is del of minus t. Same signal will get. This way del of t is even signal. That is important. And the next property is del of some a into t, that equal to 1 by mod a del of t. Okay. So this is important property, and I will derive this property. To derive this, I want to discuss some more things. Okay. So suppose some x of t equal to some a into del of t. Okay. What is this a? This a is not amplitude. Okay, I already discussed this in the first class, but again I want to discuss this. A is not amplitude. This A is area. Why? Okay. What is the definition of del of t? This is del of t. So this is del of t. So del of t equal to infinity at t equal to 0 and 0 for t not equal to 0, and del of t equal integral of minus infinity to plus infinity del of t dt equal to 1. Okay, this is the definition. At t equal to 0, del of t equal to infinity. Okay, so a is not amplitude. What is amplitude if you want to calculate? In fact, what is the amplitude? Del of t at t equal to 0 is infinity. So here at t equal to 0, infinity multiplied by a, you will get infinity only. So if you really want to calculate amplitude the amplitude of x of t is infinity. Okay, so not a. So a is area of x of t. So otherwise calculate the area of x of t equal to integral of minus infinity plus infinity x of t dt. This is the calculation of area, that is integral of minus infinity to plus infinity. What is x of t? A times del of t dt, that equal to a into integral minus infinity plus infinity del of t dt. Calculate a into 1. It is a. Integral minus infinity plus infinity del of t dt is 1. So that is a into 1 equal a. So this is area of x of t. We got a. So a is not amplitude, a is area. Okay. Next, if I want to represent an impulse signal with area A. Then how to represent? So I will represent this impulse signal as A into del of t. Okay, this is any signal x of t. So I'm defining some x of t as an impulse signal with area A. Then how to define? That is A into del of t. This is x of t. Suppose if x of t equal to some 10 times of del of t, which means this x of t is an impulse signal. X of t is an impulse signal with area 10. If I represent like this, okay. So these sentences are also important, okay. So now come to the proof of del of at. So now del of at, okay, this is x of t, let us say, okay. So del of at is impulse signal because we represented with del. This is impulse signal, okay. This is impulse signal. So I want to calculate area of x of t. Calculate area first. Integral minus infinity plus infinity. This is area of x of t. X of t dt. What do you get? Integral minus infinity plus infinity del of at dt. Okay. This I have to calculate. So I don't know del of at what it is. So I will change the variable t here. So at equal to tau. Let us say a into dt equal to d tau, dt equal to d tau by a, and the limits also changed. Why? So here the t limits, these are t equal to minus infinity plus infinity. For t equal to minus infinity, tau equal to a into minus infinity, you will get minus infinity only. For t equal to plus infinity, you will get t equal to plus infinity. Okay. So dt equal to d tau by a. Okay. Substitute all these things. The area equal to, so tau equal to minus infinity plus infinity del of tau dt is d tau by a, 1 by a integral of tau equal to minus infinity plus infinity del of tau d tau. So this value is 1. Okay, this is just a dummy variable tau, del of tau. You can replace the tau with t, del of t dt. So area under the curve del of t is 1, that is 1 by a. You got area is 1 by a. Area of x of t is 1 by a, but x of t is impulse signal because we represented with del. So how to represent this? Any signal x of t, if it is impulse signal, we have to represent it with area multiplied by del of t. So here x of t is del of at is an impulse signal which has area equal to 1 by a. And how to represent this? So del of at, let's say x of t equal to its area multiplied by del of t. Okay, already discussed this. What if a is negative? Okay, here if a is negative, the limits will be changed. Okay, suppose a equal to minus 2. Here, suppose here if a equal to minus 2, what you get? Minus 2 into dt equal to d tau. So dt equal to minus d tau by 2. Limits also changed. Here t equal to minus infinity, you will get tau equal to plus infinity. For t equal to plus infinity, tau equal to minus infinity. Limits also changed. So here we have minus d tau by 2 and limits are plus infinity to minus infinity. So you can again change the limits minus infinity to plus infinity, then this minus will be cancelled. Okay, so in both the cases you will get positive only. That is why I am writing this del of at as in both the cases you will get positive. Whatever a is negative or positive. That is why I am putting mod a to del of t. Okay, or otherwise you can write it from the property of um, even symmetry, because del of minus at equal to you will get del of at only. Whatever may be the a positive or a negative, whatever, del of minus at also del of at. So del of at equal to 1 by mod a del of t. Important property. Okay, the first property. The next, second property. So del of t into x of t, that equal to x of 0 into del of t. Okay, why? So del of t exists only at t equal to 0. All other time instants of times del of t is 0. So there is, I will represent graphically, then you can understand easily. This is t, this is x of t. Anyway, this signal is x of t, random signal. Let us say this is del of t. Del of t exists only at t equal to 0. Okay, yes. What we are doing here, del of t multiplied with x of t. So at t equal to 0, let us say x of t has x of 0. Okay, we are multiplying these two signal. What you get? You just get x of 0. So here only x of 0 multiplied with del of t. Okay, del of t at t equal to 0 is infinity. In fact, if you want uh, amplitude, you will get infinity at t equal to 0. But we don't need this. We don't need amplitude. So we want this x of 0 multiplied with del of t. That's it. Okay, that is, this signal has area x of 0. Okay, let us say some y of t, this one. Okay, this y of t has area x of 0, because y of t is an impulse signal which has area x of 0. Okay, it is that type of understanding also important. Del of t into x of t is x of 0 into del of t, is one important property. And third property, some del of t minus t naught into x of t. Is del of t minus t naught means shift the signal, impulse signal, by t naught. That is t naught. Let us say this is del of t. This is del of t 0. Shift the signal towards right side by t naught. So let us say some t naught here. Okay, you are multiplying this signal. Let us say any signal x of t. Okay, this is x of t. So this signal, this impulse signal del of t minus t naught, this is impulse signal, exists only at t equal to t naught. You are multiplying this impulse signal with x of t. Let us say x of t has value, x of t has value at t equal to t naught as x of t naught. You are multiplying these two. What you get? X of t naught into this impulse signal. So x of t naught into that impulse signal del of t minus t naught. That's it. Okay. If you want to represent this graphically, you will get only at t equal to t naught. This is exist x of 0 into del of t minus t naught. This the, the next property, fourth property. The next property, the fourth property, that is a del dash of at, where del dash means d by dt of del of at. Okay, so first I derive this and write here. So what is del of at first? Del of at equal to 1 by mod a del of t. Okay, now differentiate on both sides with respect to t. So del dash of at and del dash of at, this is argument at, so we have to differentiate argument also because it is not t. So a into 1, that equal to 1 by mod a del of t. Okay, what is 1 by mod a del dash of t? We are differentiating both sides. Del dash of at, that equal to 1 by a into mod a del dash of t. Important, this is 1 by a into mod a into del dash of t. Okay. Next, the fifth property. So integral of minus infinity to plus infinity sum x of t into del of t, that is x of 0. So we already know this integral minus infinity to plus infinity x of t into del of t is x of 0 into del of t, and that is x of 0 is constant, integral minus infinity to plus infinity del of t dt. This is x of 0 into 1, that is x of 0. Okay, and here itself I will discuss one more. Integral minus infinity to plus infinity x of t into del of t minus t naught into dt, it is x of t naught, because del of t exists only at t equal to t naught, so x of t naught into del of t minus t naught, this is the property, and you can bring x of t naught outside and integral minus infinity plus infinity del of t minus t naught, that is area of del of t minus t naught, that is one only. You shift the signal, area will not change. Okay, the area is one only, that is why 1 into t naught is x of t naught. The sixth property, integral of minus infinity to plus infinity d by dt of dt power n d power n by dt power n of del of t into x of t dt. So this I can write as integral minus infinity plus infinity. I can write minus 1 whole power n. This is the property of integrations. Minus 1 whole power n into d power n by dt power n of x of t into del of t. You can write this. Whereas, so let us say this as some y of t. Okay, integral minus infinity plus infinity y of t del of t is, now get y of 0. We already derived this. So what is y of t? Minus 1 whole power n d power n by dt power n of x of t, x t equal to 0. Okay, I will write this. Minus 1 whole power n d power n by dt power n of x of t at t equal to 0. First find out d power n by dt power n x of t and substitute t equal to 0. That is the answer. Okay. The seventh property, del of t plus a into t plus b equal to. So first this is a delta function. So where the delta function exists? Only at this argument equal to 0. only this argument equal to 0, then only delta function exists, otherwise this entire function is 0. So I will put this argument as 0, t plus a into t plus b equal to 0. So if you substitute t equal to minus a, you will get 0. If you substitute t equal to minus b also, you will get 0. So either t equal to minus a or t equal to minus b. In both the cases, you will get 0. This argument as 0. So in both the cases, delta function exists. The first case, I am putting t equal to minus a. So delta of t plus a into, if you substitute t equal to minus a, you will get 0 here. Okay. So t plus a into, in place of t, I will substitute minus a plus b. Okay. In this case, signal exists. Okay. This is exists. Delta function exists here. Because at t equal to minus a, you will get this term, this whole term 0. So only at t equal to 0 only the impulse signal exists. In the second case, at t equal to minus b, so del of, in place of t, substitute minus b plus a into t plus b. This. So if you substitute t equal to minus b here, you will get 0. So del of 0 into anything 0. So impulse exists. Okay. What is the value? Value is infinity only. Okay. Its area is 1, value is infinity. That is impulse. So from this, what is the property? This, from this, del of some constant multiplied by t plus a, we get 1 by minus a plus b mod into del of t plus a. Okay. And here here so this is the constant term, this is del of t plus b, so 1 by minus b plus a mod into del of t plus b. Okay. So these are the existing signals. So and these exists at t equal to minus b and t equal to minus a only. And what are those signals? This one and this one. Okay. So I will represent these signals in graph on a graph. Then you will get some feel. So first, what I got, 1 by minus a plus b, 1 by mod of minus a plus b into del of t plus a. T equal to minus a, I have at t equal to minus a, what is the signal? Del of t plus a into t plus b. This is the original signal, equal to t equal to minus a, I got 1 by b minus a into del of t plus a. And at t equal to minus b, I got del of t plus a into t plus b equal to, substitute t equal to minus b, 1 by minus b plus a mod into del of t plus b. So at t equal to minus a and t equal to minus b only signal exists. All other cases 0. So I have to represent this on a graph. This is t. Okay. So how to represent these signals? So this one. So 1 by mod of b minus a is area. Okay, area multiplied by del of t plus a. So del of t exists at t equal to minus a. This is minus a, let us say, which has, this is impulse signal del of t plus a, and which has area 1 by b minus a, 1 by b minus a, 1 by mod b minus a. This is how we have to represent. If I represent this like this, this is the area. Okay, 1 by mod b minus a is the area, and this exists at t equal to minus a. And this one also I have to represent. And what is this area? 1 by minus b plus a. Let us say minus b is here, and this has area, same area, minus b, 1 by minus b plus a mod. So we have put here mod. So a minus b and b minus a, whatever, if you get negative, you have to write positive only. So in both the cases you will get same value. we'll get some positive value. A minus B mod equal to B minus A. Okay, you will get same value in both the cases. So this is graphically represented this entire signal. So how can I write this signal? Okay, the signal can be written as, these are two signals, sum of two signals, one by I will write this these two areas as 1 by B minus A only. It is your wish. You can write 1 by mod A minus B also. 1 by mod B minus A into del of T plus B plus this signal. Addition of two signals, these are, plus 1 by mod B minus A into del of T plus A. Okay, that's it. So I will write this entire, so I will write this property del of T plus A into T plus B equal to, first substitute T equal to minus A, you will get B minus A, that is 1 by mod B minus A into del of T plus A, and then substitute T equal to minus B, you will get minus B plus A. Anyway we are doing mod, so can write 1 by mod B minus A into del of T plus B. So you can bring common 1 by mod B minus A, del of T plus A plus del of T plus B. Okay, right. And one more property I haven't discussed, we'll write here itself. So eighth one, so del of sum A T plus B, it equal to, you can make A common, T plus B by A. So del of A into some function T plus B, you can write this as 1 by mod A del of T plus B by A. Okay. That's it. Yeah. I'll write all the things in a single slide. All the properties. The properties of del of T. So first is even. Del of T is even. That is del of minus T equal to del of T. Next, del of AT scaling equal to 1 by mod A del of T. Next, third one, del of T into x of T equal to del of T into x of 0. Next, integral of minus infinity to plus infinity del of T into x of T, this x of 0, and here itself. So some one I will say del of T into, sorry, del of T minus T naught into x of T, that is x of T naught into del of T minus T naught. Second, integral minus infinity to plus infinity del of t minus t naught into x of t. I will get x of t naught. Okay. This fifth one, del dash of at equal to 1 by a into mod a into del dash of t. Next, sixth one, integral of minus infinity to plus infinity d power n by dt power n of x of t into del of t equal to minus 1 whole power n into t power n by dt power n of x of t at t equal to 0. Seventh one, del of at plus b equal to 1 by is 1 by mod a del of t plus b by a. Yes, eighth one, I'll write with another color. This is eighth one, del of t plus a into t plus b equal to 1 by b minus a into del of t plus a plus del of t plus b. Okay. These are all the properties